Packaging is the technology of enclosing or protecting products for distribution, storage, sale, and use. Packaging also refers to the process of design, evaluation, and production of packages. Packaging can be described as a coordinated system of preparing goods for transport, warehousing, logistics, sale, and end use. Packaging contains, protects, preserves, transports, informs, and sells. In many countries it is fully integrated into government, business, institutional, industrial, and personal use. Package labeling or labeling is any written, electronic, or graphic communication on the package or on a separate but associated label. History. Ancient era. The first packages used the natural materials available at the time. Baskets of reeds, wineskins, wooden boxes, pottery vases, ceramic amphorae, wooden barrels, woven bags, etc. Processed materials were used to form packages as they were developed. For example, early glass and bronze vessels. The study of old packages is an important aspect of archaeology. The earliest recorded use of paper for packaging dates back to 1035, when a Persian traveler visiting markets in Cairo noted that vegetables, spices and hardware were wrapped in paper for the customers after they were sold. Modern era tinning. The use of tin plate for packaging dates back to the 18th century. The manufacture of tin plate was long a monopoly of Bohemia. In 1667, Andrew Yarranton, an English engineer, and Ambrose Crowley brought the method to England, where it was improved by ironmasters including Philip Foley. By 1697, John Hanbury had a rolling mill at Pontypool for making Pontypool plates. The method of rolling iron plates by means of cylinders pioneered there, enabled more uniform black plates to be produced than was possible with the old plan of hammering. Tin plate boxes first began to be sold from ports in the Bristol Channel in 1725. The tin plate was shipped from Newport, Monmouthshire. By 1805, 80,000 boxes were made and 50,000 exported. Tobacconists in London began packaging snuff in metal-plated canisters from the 1760s onwards. Canning. With the discovery of the importance of airtight containers for food preservation by French inventor Nicolas Appert, the tin canning process was patented by British merchant Peter Durand in 1810. After receiving the patent, Durand did not pursue canning food himself. He sold his patent in 1812 to two other Englishmen, Brian Donkin and John Hall, who refined the process and product, and set up the world's first commercial canning factory on Southwark Park Road, London. By 1813, they were producing the first canned goods for the Royal Navy. The progressive improvement in canning stimulated the 1855 invention of the can opener. Robert Yates, a cutlery and surgical instrument maker of Trafalgar Place, West Hackney Road, Middlesex, UK, devised a claw-ended can opener with a hand-operated tool that haggled its way around the top of metal cans. In 1858, another lever-type opener of a more complex shape was patented in the United States by Ezra Warner of Waterbury, Connecticut. Paper-based packaging set-up boxes were first used in the 16th century, and modern folding cartons date back to 1839. The first corrugated box was produced commercially in 1817 in England. Corrugated paper received a British patent in 1856 and was used as a liner for tall hats. The Scottish-born Robert Garin invented the pre-cut paperboard box in 1890, flat pieces manufactured in bulk that folded into boxes. Gare's invention came about as a result of an accident. As a Brooklyn printer and paper bag maker during the 1870s, he was once printing an order of seed bags, and the metal ruler, normally used to crease bags, shifted in position and cut them. Gare discovered that by cutting and creasing in one operation he could make prefabricated paperboard boxes. Commercial paper bags were first manufactured in Bristol, England, in 1844, and American Francis Wohl patented a machine for automated bag making in 1852. 20th century packaging advancements in the early 20th century included Bakelite closures on bottles, transparent cellophane over wraps and panels on cartons, increased processing efficiency and improved food safety. As additional materials such as aluminum and several types of plastic were developed, they were incorporated into packages to improve performance and functionality. In 1952, Michigan State University became the first university in the world to offer a degree in packaging engineering. In-plant recycling has long been common for production of packaging materials. Post-consumer recycling of aluminum and paper-based products has been economical for many years. Since the 1980s, post-consumer recycling has increased due to curbside recycling, consumer awareness, and regulatory pressure. Many prominent innovations in the packaging industry were developed first for military uses. Some military supplies are packaged in the same commercial packaging used for general industry. Other military packaging must transport materiel, supplies, foods, etc., under the most severe distribution and storage conditions. Packaging problems encountered in World War II led to military standard or mil-spec regulations being applied to packaging, designating it military specification packaging. As a prominent concept in the military, mil-spec packaging officially came into being around 1941, due to operations in Iceland experiencing critical losses, eventually attributed to bad packaging. In most cases, mil-spec packaging solutions are similar to commercial-grade packaging materials, but subject to more stringent performance and quality requirements. As of 2003 update, the packaging sector accounted for about 2% of the gross national product in developed countries. About half of this market was related to food packaging. The purposes of packaging and package labels. Packaging and package labeling have several objectives. Physical protection. The objects enclosed in the package may require protection from, among other things, mechanical shock, vibration, electrostatic discharge, compression, temperature, etc. Barrier protection. A barrier from oxygen, water vapor, dust, etc. is often required. Permeation is a critical factor in design. Some packages contain desiccants or oxygen absorbers to help extend shelf life. Modified atmospheres or controlled atmospheres are also maintained in some food packages, keeping the contents clean, fresh, sterile and safe for the intended shelf life is a primary function. A barrier is also implemented in cases where segregation of two materials prior to end use is required, as in case of special paints, glues, medical fluids, etc. At consumer end, the packaging barrier is broken or measured amounts of material removed for mixing and subsequent end use. Containment or agglomeration. Small objects are typically grouped together in one package for reasons of efficiency. For example, a single box of 1,000 pencils requires less physical handling than 1,000 single pencils. Liquids, powders, and granular materials need containment. Information transmission. Packages and labels communicate how to use, transport, recycle, or dispose of the package or product. With pharmaceuticals, food, medical, and chemical products, some types of information are required by governments. Some packages and labels also are used for track and trace purposes. Most items include their serial and lot numbers on the packaging, and in the case of food products, medicine, and some chemicals, the packaging often contains an expiry, best before date, usually in a shorthand form. Packages may indicate their material with a symbol. Marketing. The packaging and labels can be used by marketers to encourage potential buyers to purchase the product. Package graphic design and physical design have been important and constantly evolving phenomenon for several decades. Marketing communications and graphic design are applied to the surface of the package and the point-of-sale display. Most packaging is designed to reflect the brand's message and identity. Security. Packaging can play an important role in reducing the security risks of shipment. Packages can be made with improved tamper resistance to deter tampering and also can have tamper-evident features to help indicate tampering. Packages can be engineered to help reduce the risks of package pilferage or the theft and resale of products. Some package constructions are more resistant to pilferage and some have pilfer indicating seals. Counterfeit consumer goods, unauthorized sales, material substitution and tampering can all be prevented with these anti-counterfeiting technologies. Packages may include authentication seals and use security printing to help indicate that the package and contents are not counterfeit. Packages also can include anti-theft devices, such as die packs, RFID tags, or electronic article surveillance tags that can be activated or detected by devices at exit points and require specialized tools to deactivate. Using packaging in this way is a means of loss prevention. Convenience. Packages can have features that add convenience in distribution, handling, stacking, display, sale, opening, reclosing, use, dispensing, reuse, recycling, and ease of disposal. Portion control. Single-serving or single-dosage packaging has a precise amount of contents to control usage. Bulk commodities can be divided into packages that are a more suitable size for individual households. It also aids the control of inventory. Selling sealed 1-liter bottles of milk, rather than having people bring their own bottles to fill themselves. Packaging types. Packaging may be looked at as being of several different types. Some identify a consumer package as one which is directed toward a consumer or household. Packaging may be described in relation to the type of product being packaged. Medical device packaging, bulk chemical packaging, over-the-counter drug packaging, retail food packaging, military material packaging, pharmaceutical packaging, etc. It is sometimes convenient to categorize packages by layer or function. Primary, secondary, etc. Primary packaging is the material that first envelops the product and holds it. This usually is the smallest unit of distribution or use and is the package which is in direct contact with the contents. Secondary packaging is outside the primary packaging, perhaps used to group primary packages together. Tertiary packaging is used for bulk handling, warehouse storage and transport shipping. The most common form is a palletized unit load that packs tightly into containers. These broad categories can be somewhat arbitrary. For example, depending on the use, a shrink wrap can be primary packaging when applied directly to the product, secondary packaging when combining smaller packages, and tertiary packaging on some distribution packs. Symbols used on packages and labels. Many types of symbols for package labeling are nationally and internationally standardized. For consumer packaging, symbols exist for product certifications, trademarks, proof of purchase, etc. Some requirements and symbols exist to communicate aspects of consumer rights and safety. For example, the CE marking or the estimated sign that notes conformance to EU weights and measures accuracy regulations. Examples of environmental and recycling symbols include the recycling symbol, the recycling code, and the green dot. Food packaging may show food contact material symbols. In the European Union, products of animal origin which are intended to be consumed by humans have to carry standard, oval-shaped TC identification and health marks for food safety and quality insurance reasons. Barcodes, universal product codes, and RFID labels are common to allow automated information management in logistics and retailing. Country of origin labeling is often used. Some products might use QR codes or similar matrix barcodes. Packaging may have visible registration marks and other printing calibration, troubleshooting cues. Shipping container labeling technologies related to shipping containers are identification codes, barcodes, and electronic data interchange. These three core technologies serve to enable the business functions in the process of shipping containers throughout the distribution channel. Each has an essential function. Identification codes either relate product information or serve as keys to other data. Barcodes allow for the automated input of identification codes and other data, and ED moves data between trading partners within the distribution channel. Elements of these core technologies include UPC and EAN item identification codes, the SCC14, the SSCC18, Interleave 2 of 5 and UCC, EAN 128 barcode symbologies, and ANSI ASCX12 and UN, EDIFACTED standards. Small parcel carriers often have their own formats. For example, United Parcel Service has a MaxiCode 2D code for parcel tracking. RFID labels for shipping containers are also increasing in usage. A Walmart division, Sam's Club, has also moved in this direction and is putting pressure on its suppliers for compliance. Shipments of hazardous materials or dangerous goods have special information and symbols as required by UN, country, and specific carrier requirements. With transport packages, standardized symbols are also used to communicate handling needs. Some are defined in the ASTM D5445 standard practice for pictorial markings for handling of goods, and ISO 780 pictorial marking for handling of goods. Flammable liquid, explosives. This way up. Fragile material. Keep away from water.